Alright, in this lesson we will talk about resultant forces. So before this lesson we saw that we can find the resultant force from two components, right? If there is a force in the y-axis and a force in the x-axis, then we can find the resultant force. But what if there are two forces like this? One is 5 Newton acting on this block, the other one is 10 Newton acting on this block, and this 10 Newton makes an angle of B with the horizontal, and this 5 Newton makes an angle of A with the horizontal. How do we find the total resultant force acting on this block and the direction of it? Okay, so first of all, let's assign A and B some values. Okay, so let's assume that A here equals to 30 degrees, and let's say that B that we have equals to 60 degree. Just suppose. Okay, all right, so we have B 60 degree. So basically, to find out the resultant force in such situation, we need to distribute them to their components, their very basic components. So if I ignore this 10 Newton force completely and think of the 5 Newton, how do we distribute the components? So if I say that the vertical force, suppose I'm writing that the vertical force equals to, for the 5 Newton it is 5 sine 30 degree, right? So we will write 5 sine 30 degree, and for the horizontal force it is 5 cos 30 degree, right? So we'll write that for, let's use a different color. For the horizontal force we will say it is 5 cos 30 degree. Now here we are completely ignoring the 10 Newton, right? For our better understanding. Alright, so the vertical force for the 5 Newton is this one here, and the horizontal force for the 5 Newton is this one. However, there is another force, right, the 10 Newton. So we will add that to the vertical force. So what is the vertical force due to the 10 Newton here? I can simply say that it is plus 10 sine 30. Oh, my bad, sine 60, right? Because the angle of the 10 Newton is B and B is 60 degree. Sine 60 degree. And for the horizontal force, it's as easy as that. It's 10 cos 60 degree. Alright, so just finding the values, we will have vertical force equals to 5 sine 30 degree plus 10 sine 60 degree. That gives us a value of 11.2. Let's write 11.2 Newton, right? Because it's a force. Let's talk about the horizontal force now. So for the horizontal force, if we add them up, that is 5 cos 30 degree plus 10 cos 60 degree. It is 9.33. So let's write 9.33 Newton. Alright, so we have the vertical force and the horizontal force. What does that mean? First of all, you need to understand something very clearly. That is, each force here you see, for example, if we are talking about the 5 Newton force, the green one, it's actually two force, right? It's a force on the vertical and it's a force on the horizontal. And these two forces result in this one. And if we are talking about the 10 Newton one, again it is a vertical force and a horizontal force, and both of them are the result of this one. So if we just remove this for a while, just ignoring these two forces, we can say that the components, right? So the first part of those forces, for example the vertical forces, both of them add up, and these also add up, right? Because the vertical forces are in this direction, so one force plus another force. Same goes for the horizontal force. The first force for the 5 Newton and the second force, the horizontal component of the 10 Newton one. So based on that we can just add them up, right? We can just add them and find it. So these are exactly the component, and now if I remove them, I can just simply say that there is a vertical force here which is 11.2 Newton, 11.2 Newton, and I have a horizontal force that is 9.3 Newton, 9.33 Newton. Well, just let's draw a brick here to make it understand easier. There should be a brick, right, where the forces are being acted. Okay, so in this brick the force was acting. Pardon me for removing it. So we have now two forces, right? One vertical force 11.2 Newton and the horizontal force 9.33 Newton. So we know how to find the resultant force from two of these, right? We know how to find a resultant force from a vertical force and a horizontal force. It is as easy as that. So how do we do that? We do Pythagoras, right? So we can say that the resultant force R equal R square equals to 11.2 square plus 9.33 square, and then we can solve it for R, and then it's just calculations, and if you calculate you will find the answer, that is whole root 11.2 square plus 9.33 square. So the answer is 14.6. So here we can say that it's 14.6 Newton. So the resultant force from those two forces we saw before is 14.6 Newton. Let's just draw force 14.6 Newton here for better understanding. This is the resultant force 14.66 Newton or 14.6 Newton. How about if they ask me to find the angle of the resultant force? So if they ask me to find the angle of the resultant force, it is pretty easy, right? What I do here is that I'll write the angle. For example, tan theta equals to, now if I want to find this angle, it's always opposite by adjacent, right? So the opposite one is a vertical force. If we like draw an angle line here, you see tan theta, let's put it theta. We know this one it's 11, we know this one it's 9.33, so it's 11.2 by 9.33, and you can find the answer easily, the value of theta. However, I would like to show you a different scenario here. So suppose that you have a field here and you have a block. Let me draw a block. These are always easier to understand. A block. So suppose that I have two forces in different direction. One in this way, but the other force will be in a completely different direction. For example, I have a force in this way. In such scenario, where will the block move? This is very important. First of all, you need to understand something, that is, suppose I'm actually removing this ground, it's confusing. Suppose it's a block in the air. There is nothing, there is no friction, there is nothing, it's in space. So I have two forces here, one is acting in this way, the other one is acting this way. Right now, if I draw a graph like this, let me just move it to its place. Suppose it's here, right? Alright, let's think that it's acting on a point. These two forces are acting on a small point, a small ball, for example, which is here. A small ball here, suppose it's a ball. Okay, so what we do in this scenario? First of all, when we do the components, for example, let's name this F, and let's say that this is suppose this is 30 degree, and let's name this G. Let's use blue for it. Let's name it G, and let's say that this is 20 degree. Suppose it's not accurate, right? Just suppose that it's 20 degree. What do we do in this case? So remember, if we are finding the vertical force, for example, for this one, it is F sine 30 degree, right? F sine 30 degree. Let me just make it a bit smaller so that you understand the diagrams go a huge one. They become huge. Yeah, this is better. So this one is F sine 30 degree, right? How about the G? How about the vertical component of G? So you see G is downwards. So we can say that the vertical component is negative, right? Because it's going down. The force is going down. So we can say that the component of G is, suppose, G sine 20. But you see G sine 20 degree, but the direction, that's very important, it's downwards. Now you might say that why will I say that G is downward? I can, yeah, G is downwards, just think like that. So while calculating the vertical force, I should write Vf equals to F sine 30 minus G sine 20, right? So it should be F sine 30 minus G sine 20, as easy as that. So suppose in this scenario, for some reason, this one is a smaller value and this one is a larger value. So what do we get in those sense? For example, this F sine 30 is, suppose the F sine 30 is 5 Newton and this G sine 20 is 7 Newton. So you have 2 Newton, not really, you have minus 2 Newton. Why do you have minus 2 Newton? So basically think it like this. You thought or you assumed that this direction is positive, right? So you found this vertical force, but it is negative. What it means is that the resultant force is acting downwards. Because you thought that this upper portion is positive, you're thinking that the upper direction is positive. So in this case, if the upper direction is positive and you have minus 2 Newton as your vertical force as in the total of this vertical force, it means that the resultant force is acting downwards. As simple as that. And then what you can do is that you can find the for horizontal components, and these are gonna be just like before, the one we did. Here it's gonna be the same, we just add the two forces up. And then you might say that how would you find the resultant force? Well, you see the resultant force is r square equals to minus 2 square, right? Because it's the Pythagoras formula is minus 2 square. So it's alright, it was gonna be removed, right? It's r equals to, because you removed the root in that case. Okay, so r square plus, suppose that if we add this horizontal component, it's 5, just assume. Okay, so suppose it's 5, then 5 square. So you see this is going to be positive because we are just finding the magnitude of the resultant force. So this in turn will turn into positive. So suppose if this one's positive, then the value is 2 square plus 5 square whole root. It's 5.39. Alright, so suppose it's 5.39. And now this is very important and you need to understand. Suppose I'm drawing this resultant force only the resultant force, nothing else. Let me draw a whole thing right like this. Yeah. So suppose that this is it and I'm drawing the resultant force, the 5.39. Don't get confused. So you see, we know that the resultant force is downwards and all the horizontal force is to the right. So we can say that the resultant force is downwards and towards the right. Suppose it's like this. Alright, so how do you find the direction? If they ask you to find the direction, what do you do? So here you can do a lot of things, to be honest. You can say that you can find this angle. Suppose this one is theta, right? Yeah, it's theta, so you can find this angle. Now you might say that while finding this angle, you might say that what would you do with the -2? So we know that to find the angle, the shortcut is tan theta equals to vertical force by horizontal force, right? But we have a vertical force of 2 Newton and a horizontal force of 5 Newton. Just saying, assumption, right? We don't know the real values. So if we do this calculation, what do we find? We find an answer of minus 21.8 degree, right? Minus 21.8 degree. However, if you are say like writing the answer of the direction, you can write this, it's accurate, it's not wrong, but I will recommend you to write 21.8 degree below horizontal. That's how you write the direction. So if it's below the horizontal line, you can write minus 21.8. Minus shows that it's below, but it's better to write 21.8 degree below horizontal. Below horizontal. Pardon my handwriting. Horizontal. Alright. So that's the end of this lesson. However, in this lesson I will be adding some questions which will be directly from the past papers. So you might find them a little bit difficult, but hey, practice is everything in mechanics. So look at this video again and again, and if you do not understand the concept, you can contact me and I can help you with a one-to-one peering session, for example. And that's it. Best of luck for the quiz.